Hello, I'm so happy that I have a chance to present my paper. And in this paper, we propose a new framework and a new approach for modeling legal requirements using first order logic and a new category of rights. Let's look at the table of contents. So we first start with the problem statement, and then we introduce our contributions, and we look at the related work, and we overview our framework. Then we talk about the evaluation and limitations of this framework. And at the end, we have the conclusion and future work. The big problem of legal requirements engineering is about capturing legal requirements and modeling those requirements in a way that it's easy to understood by everyone, system designers, requirement engineers, those who are involved in developing a software or application or website. And the main problem is with the law. The law has a sort of complicated language, so it's not easy for engineers to understand that language. And uh, with this framework, with this approach that we have proposed, we want to overcome these complexities. And this complexity is partly because of the process of modeling, in which you need close participation of legal experts and requirements engineers. And at the end, the final models are also complicated because you have legal terms and model language and some other considerations which are just unique to legal language. So our paper actually is based on a legal ontology that we have proposed in our previous work, and it helps us to simplify the conceptual structure of the legal documents by working on the modality of the legal text. And beside, it has a syntactical structure for legal statements, so that we can have a formal ontology for the legal requirements. And for this purpose, we propose our legal ontology, and then we actually develop a database, and we use that database to store and retrieve data. And when we do the retrieval, it's automatic, and then we can actually generate the legal requirements models in GSIM-nav, which is a tool support for requirements modeling. And this process is semi-automatic. I mean, once you capture the requirements and you imported the data into the database, you can do the rest of the modeling process automatically. So this automation of requirements modeling is a big achievement comparing with the other alternative approaches like legal GRL, which is manual. Legal GRL, Nomos, GBROM all have good contributions in goal modeling and legal requirements engineering, but uh, they they tend to include the complexity of the law into the goal models, which is not something really good for those technical people who are not really good at law, and they're not comfortable working with legal texts. So there is a extra burden for them to understand and analyze these statements, which are still in the original structure and original um, legal text. Uh, Semantic parameterization and legal markup are the other approaches that they propose a formal ontology. They are actually really good for analysis of the statement, but still they don't have the visual modeling visualization for the models, for the final models, or at least the final models are not really easy to be understood comparing with GRL models, which are they have illustrations, and it is easier to analyze them, to understand them for different scenarios. So we propose this FLG, or first order logic based legal GRL framework, which has three phases. Phase A should be done by legal experts, and they have to collect the relevant documents and use the legal ontology to process the documents and come up with restricted natural language statements. They put these statements in a document and turning the document to requirements engineers to do the second phase, which is data storage and retrieval. Engineers use a database to store the data and extract the data in a structured way, in a XML format, which is useful to be imported uh, as a GRL file in phase C. Last phase is importing that XML file into GCMNav and automatically creating the goal model. So now we look at details of each phase in the following slides. Phase A, legal requirements extraction. This phase has several steps, identifying relevant documents and resolving cross-references. Should be done manually by legal experts, and we don't have any contribution for this part. But we have three extra parts, extra steps, and that's converting the modalities of legal statements using a legal ontology or category of right that we talk about in the next slide, and then converting these statements to factual statements and to a restricted format using first order logic, and then further analysis and validation of these statements. So we are using our legal ontology, which is a consequentialist ontology in which the consequences of the legal statements are important. And the most important consequence for a legal text is the obligations. So the obligations come in various forms of duties, disabilities, prohibitions. And on the other hand, we also, in a legal document, we have non-obligations like rights or exceptions or permissions, which are not mandatory, but they have obligatory consequences. So legal experts have to use this legal ontology in order to process the legal text. For example, this article from FIPA is wants the researcher to actually not disclose the information except as required by the law. So here we have several elements, researcher, which is the actor, and shall not, which is a modality in form of prohibition, and exception, which affects the obligation here, the prohibition. And legal experts can use the legal ontology that we have proposed here to come up with the scenarios. So we have three possibilities to satisfy this this requirement, this sentence, and that is either researcher do not receive personal health information, or they do not disclose it, or the disclosure is required by the law. And we can achieve these alternatives, these different scenarios, by processing the original legal statements using our legal ontology. And here there are elements that are important for us: the actor, the subject, and the action, plus the connective between the statements. So we put all of these restricted natural language, which are in this format of actor, subject, action, and connective, in a file, and we give it to the uh, system engineer or requirements engineer in order to put it into the database. So now we're going to talk about the database. This database has several tables. The most important table is table sentence, which entails all the restricted natural language statements. And as you see here, each row on this table has one ID for that sentence or for that statement, which is connected to a paragraph, and it contains an action, actor, subject, connective type of that statement to other statements, and the element type, which mentions to the element type in the final model, in the goal model. And after importing the data into our database, we can do the retrieval step, and we run some XML queries. For example, here we select element ID, its description, its title, whatever it is, the type that this element has, the decomposition type that it has, from table sentence, and we turn the output into XML. And the XML file, the XML output actually is convertible to GRL. We have ID, we have the title for the element, no description, element type is task, and decomposition type. So we put all these outputs together in a file, which is an XML file convertible to GRL models, and it has all the elements that we need in order to create a goal model. Intentional elements, links between elements, the actors, and the way that we attach the elements to each actor. So this file is generated automatically after running the queries, and now we can give this file or import it to GCMNav in order to automatically generate our goal model. And this phase is fully automatic. We just import the file into GCMNav, and GCMNav has a plugin for auto layout, and it creates this model as is, except there are very minor modifications, manual modifications maybe. And here we don't have any contribution about the evaluations of the models for now, different scenarios, but you can see one example of the evaluation. The top goal is evaluated and is satisfied by one of its children. And let's look at one part behind this goal for the top goal here. And that is the XML file. This is a excerpt from the XML file, and shows the intentional element is title, and its type, which is goal, and its decomposition type, which is OR. So you see that each element has its own description in the XML file, and XML file can exactly create the goal model in GCMNav. And as you see, this goal model is organized in a hierarchical structure, so it's easier to follow the scenarios. For example, here we have 3 different possibilities for satisfying this top goal. For example, for transfer subject to appropriate safeguard, either you don't transfer personal data, or there are legal exceptions, or you actually provide safeguards. So it's easier comparing with other, with at least legal GRL, to understand the final goal model. And for the qualitative evaluation of our framework, we compare it with legal GRL. You can compare this legal GRL model with the FLG model that we saw in the previous slide. There are shortcomings with legal GRL. It's manual. It needs close participation of legal experts and requirements engineers. And there are varieties of elements, soft goals and goals and beliefs and these things, and different links, different tags or stereotypes, modalities are included, and it makes it more difficult to understand it. And it's also it's harder to create it because it's manual, and to validate it because it doesn't have a formal ontology, and also to understand it. And we have also a quantitative evaluation. We've worked on 18 paragraphs of 4 documents, which resulted in 92 RNLS, and you can see the results of the evaluations here. And obviously there are many limitations for this framework, because this framework is going through its very first steps of its development. So there should be a lot of limitations, and I appreciate any feedback on this part. The main problem is with the representation of legal text in GRL. GRL is not the best language for representing textual entities. The problem is with multiple connectives and parentheses. We cannot use parentheses in GRL to do to limit the scope of each sentence, each statement. Soundness and completeness of our legal ontology is not proved yet. We have intuitive proof for that, but not formal proof. And there are difficulties with large models, goal models. And we aim to use more techniques for grouping goal models and elements to overcome this difficulty. And there are limitations concerning our evaluation. The evaluation is based on a very small corpora of legal text, and it's not enough for a comprehensive evaluation of our framework. And it is done by the developer of the framework, so it's not very reliable, or at least it's not objective. It tends to be biased. And the claim about understandability of FLG goal models comparing with other approaches is not empirically tested. And for the conclusion, so we have proposed our FLG framework, and it has a legal ontology, and it has 3 steps or phases of extraction, storing the data into database, and exporting that, and creating goal models in UCM-nav. So we have a semi-automatic framework for creating legal requirements models. For the future work, we aim to enhance our implementations for these 3 phases. We want to use NLP techniques in order to make it possible to have a less manual job for legal experts in terms of identifying relevant documents and resolving cross-references. And we are going actually to replace our database with a XML database. And also we want to link the legal requirements models with the rest of requirements models, like a systemic requirement, and in order to automate the traceability links generation in our framework. And also we want to resolve the technical problems and the limitations concerning the evaluations. in our future work. And thank you so much for your patience. Appreciate any feedback or question or any interesting comment. Thank you so much.